Okay, so if you're taking calculus and you're in the derivatives unit, you've probably been looking at the chain rule. And the chain rule is there and it's helping making calculations a little bit easier. So for instance, if you had something like 2x plus 1 squared, we know that we could use the product rule, making this 2x plus 1 times 2x plus 1, and then expanding it out how you would with the product rule. But what if it was more complicated? What if instead of having an exponent of 2, you had an exponent of 8, and then you'd have to multiply 2x plus 1 out 8 times? Not that you can't do it, but it would get a lot harder in terms, or I guess more messy, and there is a faster way of getting there, and that is the chain rule. So what the chain rule is if you have a function, you take the derivative of the outside and then you multiply it by the derivative of the inside. So for instance, looking at that same one, 2x plus 1 squared, again, you could use the product rule, or we follow the chain rule. So we take the derivative of the whole thing, so we bring down that 2 and then multiply by 2x plus 1. And then if we took that exponent and subtract 1, we just have a 1 there, so we don't have to include it. And then you multiply it by the derivative of the inside. And the derivative of the inside would just be 2. So this simplifies to 4 times 2x plus 1. And if you did distribute that 4 in, you can make this 8x plus 4. Again, the product rule gets you there too, but the chain rule is a lot quicker. One more example, if you have the root of 2x plus 1, so we can rewrite this as 2x plus 1 all to the power of a half, and then do the same thing. If we want to figure out the derivative, so f prime of x would equal, we'll take the derivative of the whole thing, so bring that half out front, multiply it by 2x plus 1, then we need to subtract 1 from the exponent, which is now negative 1/2, and then multiply it by the derivative of the inside, which is still just 2. In terms of the math, because we're multiplying, these 2's would cancel, and usually you don't want a negative exponent, so we can write the whole thing under 1, and instead of writing the exponent as 1/2, we can just take the root one more time. So 2x plus 1 is what the derivative of that would be. Moving on, if sometimes you have something a little bit more complicated, you can use the chain rule in combination with other rules. So this one here, we're multiplying. So if we're multiplying and you have something a little bit more complicated, we're still going to be doing the same thing. So remember our multiplication rule, where you're going to take your first function or first binomial and multiply it by the derivative of the second, and then you take the second and multiply it by the derivative of the first, and then you add those two together. So let's start doing that. So what I'm looking at here is if this was my f of x and this is my g of x, then the derivative of the whole thing, and I'll use capital here, and is the product rule. So you'd have, take your first one, multiply it by the derivative of the second, add on the second term, and then multiply it by the derivative of the first term. Okay, so that's our product rule, but we'll have to use that with the chain rule because we have something a little bit more complicated. So if my first one, and I'm taking x prime of the whole thing, so I'd write down my first term, so 3x plus 2, and I'm going to multiply this by the derivative of the second. So I take that 4, bring it down, and then multiply by 2x plus 3 to the power of 3. And then I have to keep going because it's the derivative of the second, which is now multiplied by the derivative of the inside, which is 2. Now I'm adding on my second part, so the second term, so 2x plus 3 all to the power of 4. And then we'll multiply by the derivative of the first term, which is just 3. So we have that. Now what I can do is simplify within and also recognize here that I do have a common factor of 2x plus 3, and my lowest exponent is 3. So I'm going to take out that 2x plus 3 to the power of 3 and also simplify as I go. So if I take it out from the first part here, this whole thing will go away, and then I'd have 2 times 4 to give you 8, and then 8 times 3x plus 2. And then from the second one, if I took it out, I'd still have 1 left over. So I'd have, I'm just going to write the coefficient first, 3 times 2x plus 3. Then I can simplify within the bracket, so distribute through and then collect like terms. So my 2x plus 3 cubed is still there. And then the next part will simplify to 30x plus 25. And then lastly, I could just see that there's a common factor here of 5. So if I take out a 5, I still have my first 2x plus 3 cubed term. But if I took out a 5 from both of these terms, I'm left with a 6x plus 5. And so that's our simplified derivative with the chain rule and the product rule. One more example here is finding the derivative when you're dividing. So just to rewrite this question here, it is 2t plus 1 divided by t minus 2, and this is all to the power of 4. So writing the derivative like this is just the notation. It's just another way of saying the same thing. So when I want to write my derivative, I'm now going to be using the same rule. So I'm going to start with what we talked about when we first looked at the chain rule a few slides before. You take the derivative of the whole thing. So if I'm looking at the derivative of s, taking the derivative of the whole thing will be 4 times 2t plus 1 over t minus 2, all to the power of 3. Then I need to take the derivative of the inside, and the inside is division. So now I'm going to have to apply my division rule, or the quotient rule, which is you take the denominator term and multiply it by the numerator's terms derivative, which would just be 2. Then you subtract the numerator term, plus 1, and you multiply that by the derivative of the denominator, which is just 1. Then you have the the denominator term squared, right? So this is just a quotient rule. We can simplify what we can. So we still have everything in the front here. So I'm just going to rewrite this. And we're multiplying. We still have the t minus 2 squared, or not squared, sorry, this is times 2. And then times with 1, but we're distributing that negative through, so then we'll have minus 2t minus 1 all over t minus 2, and this is squared. And then let's go up here for some more space. We still have that 4. I'm rewriting it quite often here. Plus 1 all over t minus 2 to the power 3 times, if I distribute that 2 through, it would have been 2t minus 4 minus 2t minus 1 all over t minus 2, and this was squared. Then things are starting to cancel out nicely from the numerator, so the 2 t's would cancel, and then negative 4 minus 1 would be negative 5. So we would have 4 times the 2t plus 1 over t minus 2 all to the power 3 times negative 5 over t minus 2 to the power of 2. We can simplify this a little bit further, knowing that this exponent of 3 applies to the numerator and the denominator, and we can take our coefficients and multiply to get negative 20, and then we'd have 2t plus 1 cubed in the numerator over, and then if there was a 3 here applied as well, and then a 2 here and you're multiplying, we're going to add exponents. So t minus 2 all to the power of 5. So lots of work there, but we still get to the same place. As always, I hope you found this helpful. We're almost done the derivatives unit. I'll do one more video to wrap that up, including a review. And again, if you're taking chemistry, please check out my channel, including my website, for lessons on everything of chem. Thanks for watching.